Okay, we're looking at explore number 3 from Evidence for Evolution. The essential question: what do morphological and developmental homologies tell us about common ancestry? So go ahead and draw out your Cornell note template and tell me what you know or you think. Hit pause for just a moment. Okay, well, hopefully you've got that all kind of squared up and you've written down a few ideas about what you think. So, what is a homology? A homology is a similarity in morphological features resulting from common ancestry. It's a lot there, I know. Homo, of course, means same. And probably the best example is to take a look at this image here. What you consider to be your arm, we refer to as a forelimb. And we're looking at the forelimbs of 4 mammals: humans, cats, whales, and bats. And even though to a casual observer, we would look at the arm of a human and argue that it was very different from, say, the arm of a bat, or the arm of a whale, or arm of a cat. They seem like they have different functions, they have different shapes, but if you were to take a little closer look, you would see that we'd had homologous bone structures. Again, similar bone structures. We all have a humerus bone. That's that proximal gray bone there. We all have a radius and an ulna. Radius, ulna, radius, ulna, and radius and ulna. We also have our carpal bones and we have our metacarpal bones, right? Carpal bones and metacarpals. Carpal bones and metacarpals. So these are what we refer to as homologies or homologous traits. One thing to remember is that, and we've got a note right here for ourselves, not all structures that look alike or perform the same function are homologous. Okay, similar structures may evolve independently in different groups of unrelated organisms. We call this convergent evolution. Flight would be an example of convergent evolution. Birds have figured out how to fly. Mammals, if you think about bats, have figured out how to fly. Insects have figured out how to fly. Okay, different groups, unrelated organisms who have converged upon the same solution for a certain environment, right? And we see that with swimming in the oceans, mammals that have converged on a streamlined body, flippers, living in the water. Not only include your whales and your dolphins, but it also includes things like your manatees, what we call a sea cow. So that's another example of convergent evolution. The only other point that we need to cover here in your text is related to developmental homologies. Sometimes we see clues to common ancestry, not in the fully formed adult body, but during the embryological stages of development. Classic examples include things like tails. When you take a look at humans, we have a tail structure just like a chicken and a pig, right, and a chimp. All the mammals have these tails. Now, whether we have them in our full adult version or not, that's a different thing. Obviously, humans, we just have a tailbone in our adult fully formed version, but embryologically in the developmental stages, we see homologies between the different mammals. Okay, clues, right? Clues to our common ancestry. Okay, well, let's go ahead and make sure to pause the video and write yourself a summary paragraph, and we'll talk to you soon.